ASP.NET Core can be developed using the tools used to develop any .NET application. The most commonly used is Visual Studio by Microsoft. It comes in a number of editions. The downside of Visual Studio is that it only runs on Windows. There is a separately developed Mac version, however, with a slightly different development experience in which not all the features of the Windows version are available. Rider by JetBrains is an alternative to Visual Studio. It runs cross-platform on Windows, Linux and macOS, offering the same developer experience across the different platforms. Visual Studio and Rider are called IDEs, Integrated Development Environments. They have support for everything a developer needs, such as the ability to write and edit code, build it, run it, debug it, and deploy it. Visual Studio Code is also commonly used, but it is different. It focuses more on code editing, not just of the .NET languages, but almost every programming language in existence. You can still do all the other things I mentioned, but it is not integrated in the tool. And that's why Visual Studio Code is often used together with the command line interface or CLI tools .NET offers. .NET on the command line is part of the Software Development Kit or SDK of .NET, and it can do a lot of things like create a new build or running the code. Since it's the most commonly used tool among .NET developers, I will use Visual Studio during the coming code examples. In the next clip we'll see how an ASP.NET Core application starts up. To explain the commonalities across all styles of ASP.NET Core applications, I'm using the application you start out with when you start a new ASP.NET Core application with Visual Studio. Every ASP.NET Core application starts its life as a normal command line application. When the application is started, the code in Program CS is executed. First, a builder object is created, which is then used to get an app object, which is finally commanded to run. Once run is executed, the command line application has turned into an ASP.NET Core application. Let's run it and see what happens. In Visual Studio, that is done by pressing the Run button, which will start a debugging session. But when using a code editor, it is also possible to open up a terminal and type .NET Run using .NET's CLI tools I mentioned earlier. The browser is opened, showing the default web page. But there is also another application running, which looks like a console application. There is some logging. It seems to listen on a URL that matches the URL in the browser. So that means that our web application contains its own web server, and browsers can talk to it directly. This built-in web server is called Kestrel. Kestrel is great because developers now don't have to be concerned about configuring a web server to run the application on while developing the application. They can simply run the project. However, when running application in production, Kestrel often doesn't suffice because it's likely that you have multiple web applications running on one server, and you want to have a single place to manage and monitor them. Or maybe scalability is needed, or other web server features Kestrel lacks. In that case, it is a possibility to put a web server in front of your application, such as IIS when you're on Windows. It is used as an example on this slide, but Nginx in Linux also works, for example. This web server will then use the .NET CLI tool to run the application and keep it running. Incoming requests to IIS will then be forwarded to Kestrel, and responses will flow from Kestrel to IIS. Developers can mimic this behavior at development time by choosing IIS Express from this drop-down, and then run the application as normal. IIS Express is the version of IIS that is used for development purposes. Dependency injection is also vital for ASP.NET Core applications. We'll see how that works next. I'm returning to the program.cs file in the application. The part just above the line that creates the app object registers services in the dependency injection container. Dependency injection is an essential part of every ASP.NET Core application. The container is a central place in which types can be registered. Each instance of the type will have a lifetime, which is determined at registration time. Once the registration is done, we can ask for an object instance anywhere in the application. The object will be automatically instantiated when we first ask for it. Builder.services is the object to do the registration on, before the actual application is started. Add Razor Pages here is an extension method that registers all needed types for the Razor Pages engine. As you might remember, Razor Pages is one of the application styles ASP.NET Core offers. You can also register your own types in a dependency injection container. You'll learn how to do that in the next module, where I will show you the first demo application. I'm discussing the rest of program.cs next. In the program.cs file, the part between the creation of the app object and running it consists of method calls on the app object that mainly start with the word use. We're setting up the internal request pipeline here. This is the part where we're opting in on the ASP.NET Core features. Once a request reaches our application through Kestrel, it is processed by a number of steps that make up the request pipeline. These steps are called middleware. All middleware in order will have the chance to do something with the request, forming the response. If you don't configure any middleware in your application would simply do nothing when it receives a request. We have to plug in middleware for routing, which maps the URL used in the browser to a part in our application. And when we want to make static files, such as images and CSS and JavaScript files available, there is middleware for that. And the same goes for authorization. So in the code you'll find use routing, use static files, and use authorization, which are all extension methods that set up the middleware in the pipeline. Use routing in this case enables a general routing feature, and map Razor Pages will make sure that the URL is mapped to a corresponding Razor page. This last part is specific for the application style Razor Pages. The order in which middleware is plugged in is important, since the request data travels through the middleware in sequence. Before showing a Razor page at all, you want to do authorization, for example. There's something else to say about the static files middleware. Only files present in the www root folder can be accessed by this middleware. So all static files should be in there. All other files in the project cannot be downloaded directly. There are many more examples of built-in middleware, and there's also the possibility to create your own. You'll see the way to write the UI part of an ASP.NET Core application next. All front-end application styles have one thing in common: the way the UI, the pages or views, can be designed. It is done using Razor. Razor is basically HTML with the option to embed C# code. To show you what I mean, Here's the file called error.cshtml from our Razor Pages example project. The Razor Pages application style, of course, gets its name from the Razor we're talking about in this clip. The CSHTML extension stands for C# with HTML. In the same way VB.html files exist, Visual Basic with HTML. We'll soon see, however, that in Blazor, Razor files simply have the extension Razor. At first glance, this error.cshtml file seems to be just a normal HTML file. But when you look closely, there is embedded C# code. For example, there is this if statement that checks the Boolean property showRequestID on a model object. If it's true, a p-HTML element is rendered, and that shows the requestID property also from the model object. Notice that every time we begin a C# statement or expression, the @ sign is used. If we leave out the @ sign, it will just literally show model.requestID and not evaluate it as an expression. Code blocks are also possible by using the @ sign followed by curly braces. In such a block, multiple lines of code can be written ending with a semicolon. I could, for example, add a line that declares an error text variable and refer to it somewhere in my HTML markup. ASP.NET Core will make sure that the code in Razor files is processed before the browser shows it to the user. Now it's about time I told you the specifics of the different application styles.